All right, so in this video, I want to factor these cubic or quartic equations, polynomial equations, basically, and I'm mostly going to use factor theorem and synthetic division because that method works pretty much most, if not all, the problems. In this first problem here, I have a cubic equation. I want to do factor theorem to find which factor I can actually divide this equation by. So you want to take multiples of the last number at the end over here. I'm going to start by finding f of 1. I'm going to do this in my calculator to make things a bit more efficient. So if I put in 1 into my calculator, you get f of 1 is negative 42. So I know x minus 1 is not a factor because this solution should be 0. And if this solution is 0, then the value is going to be a factor of this equation. If 1 doesn't work, I'll move on to my next value. I'll try f of 2. So a quick way to do this, and I'll show this only once, is to just replace all the ones in your calculator with a 2, and it's going to be a lot quicker to put this in your calculator than retyping the whole equation. You should be doing this as long as you type in the first equation correctly. They should all be correct. So I get f of 2 to be 0. So I know that x minus 2 is going to be a perfect factor of this equation. So now I can do my synthetic division to actually factor it out. So for synthetic division, I'm going to put this number here on the outside 2, and I'm going to put all the coefficients of my terms on the inside here. So 1, 9, 8, and negative 60. We start by bringing our first number down. Then we multiply these two. So 2 times 1 is 2. And we add these two numbers, 11. Multiply 2 times 11 is 22. Add these two numbers, 30. Multiply those again, it's going to be 60. Add these two, and we get a remainder of 0, which should always be the case when you're factoring because we know that the remainder is 0 and we divide by x minus 2. So now I can rewrite my equation. F of x equals, I'm going to first write my factor, which is x minus 2. So I know this solution of positive 2 gives me a remainder of 0. And then I'm going to be left with a quadratic equation now because cubic, once you factor, turns into quadratic. And here are my coefficients for my quadratic equation: x squared plus 11x plus 30. Then we simply have to factor this over here. I'm going to factor it with our man method. It's a simple trinomial. So what multiplies to 30 and adds to 11? It's pretty simple. It's 6 and 5. Now I can factor this completely. I can rewrite it as f of x equals x minus 2 times x plus 6 times x plus 5, which were my two factors from there. And now this is fully factored. Let's take a look at the second question over here. Again, it's a cubic equation. So f of x equals x cubed minus 7x minus 6. So if you look at this one, it's a trick question because the x squared term is missing over here. Also, it looks like you can kind of factor this with man, but you cannot. This is cube, and then this is an x term. So we're going to have to do a factor theorem again. I'm going to start with multiples over here of this. Start with f of 1. I'll do this in my calculator again. So 1 cubed minus 7 times 1 minus 6 is negative 12. So 1 is not good. Let's try f of 2. Flip my 1s to 2s. And I get negative 12 again. So negative 2 is no good. I'll try positive 2. So I'll try positive 3 as the last one of my positive numbers. And then I'll go to negative numbers. Positive 3 actually works. So f of 3 is 0. So I know that x minus 3 is going to be a perfect factor here. I'm going to do my synthetic division again. Got 3 out here, my factor. And then over here, my coefficients. So 1 for the x cubed. Then you have to put the 0 for the x squared because the coefficient of x squared is 0. And if you skip that, you will not get the right solution. Then you have negative 7 and negative 6. start by bringing the 1 down, multiply these two, 3, add those two, 3, multiply those two, 9, add those two, 2, multiply these two, 6, and again should be 0 at the solution over here. So now I can rewrite this in partial factored form. I'll start with my first factor, which is x minus 3, and then I'm left with a quadratic equation. Those are my coefficients. So x squared plus 3x plus 2. And then we just have to factor this again with our man method. Should be pretty simple. 1 multiplies to 2 and adds to 3, 2 and 1. So I can rewrite this as x minus 3 times x plus 2 times x plus 1. And it is fully factored again. And let's get to the third and final question in this video. F of x equals x4 minus 5x squared plus 4. So now this is a quartic equation. You could do this with factor theorem and you could do it with synthetic division. You would do factor theorem twice and synthetic division twice because it's quartic. But what you also notice in this question is this is an x4, this is an x squared, this is a constant. You can just factor this like it's a simple trinomial with our man method. So sometimes there's a lot quicker ways to do this. And if you're on a test and you're very constrained for time, learning things like this will help you save a lot of time in the test and get the solution much quicker. I'll show you how quick this solution is. My two numbers here are just -4 and -1 because -4 times -1 is +4. And if I add them, I'll get -5. So now I can rewrite this equation in partial factored form. And this is going to be x squared minus 4 times x squared minus 1, because an x4 equation will turn into x squares if you factor it like a simple trinomial. Now we can just factor these with a difference of squares. So x plus 2, x minus 2, x plus 1, x minus 1. That's my final solution. Again, like I said, if you did factor theorem, you would take a lot more time and a lot more space. This is so much quicker and so much easier. So definitely want to notice if you can do simple trinomials or factoring by grouping on certain harder questions. It's always a possibility, but most of the time you'll end up doing synthetic division.